Okay, I've got a definite integral up here on the board for you folks to try. So we're integrating from 0 to pi, cosine of x times e to the sine x, integrating with respect to x. So pause the video, give it a shot, tune back in, and we'll work through it together. Welcome back. So looks like this factor is my function composition, where sine x would be the inside part. That's what I'm plugging in to the exponential function. If you find it helpful, you might want to put parentheses just to indicate that's the inside part. So I'm going to say u is equal to sine of x. That means u prime is cosine x, and lucky us, we've got a cosine x just hanging out, waiting to get absorbed into that du. So du is going to be cosine of x dx. So now I can rewrite that. This becomes my du. My integrand becomes e to the u, and I'm going to be integrating from the u value at 0 to the u value at pi. Now, the u value at 0 is what I get if I plug in 0 to the sine function. So sine of 0, that would be 0. The u value at pi, that's going to be what I get if I plug in pi to the sine function. Sine of pi is 0. So we're integrating from 0 to 0, e to the u du. That's a degenerate interval. If my limits of integration are the same, I'm talking about calculating a signed area with no base, I'm going to get 0. I don't even need to find an antiderivative. As soon as those limits of integration are the same, I know that my answer is going to be 0. Now, if you remember, back when we first defined integrating from a value to a value, sort of like, why would we ever want to do that? Of course, that's going to, be silly or be 0, or, why do we care? Well, here, this was a perfectly legitimate problem, but when we do this u substitution, we're able to see the limits of integration become the same. Now, obviously, this was not over a degenerate interval, but what happened over that interval is half the time my integrand was positive and half the time it was negative, and those signed areas canceled each other out. So either way, I'm going to get 0. Here, because I have positive and negative area canceling each other out. Here, because I just don't have any area, because I've got a degenerate interval that I'm working with. Notice, though, how important it is that we remember to change those limits of integration.